Hi everyone. This is Priya from Aarna Networks. Thank you for taking your time out from your busy schedule and being here with us today. Today's webinar is going to be on service orchestration using BPN with domain orchestration using CDS. One second, I think there is some, okay. So I would like to introduce our presenter today, Kavita. Hi Kavita, welcome.
Thank you.
Kavita is a project lead at Aarna Networks, works on ONAP related projects. Prior to Aarna, she worked as a technical architect in Accenture, worked for AT&T client, responsible for the technical solution design and development. Hi Kavita, welcome.
Yeah, thank you Priya for the
intro. So Kavita is going to help us understanding about Camunda, which is a sophisticated workflow engine that can be used for service orchestration, and CDS is a powerful configuration management, lifecycle management, templating and modeling project that can be used for domain orchestration. So she will take you further to the journey. Yeah, Kavita, you can take it from here.
Yep, thank you, Priya.
Yes.
Hi everyone. Today we'll be talking about the Camunda CDS integration. First, we will start with a brief introduction to the Camunda BPMN and then Modeler, and then we will go to the then we'll talk about Camunda architecture and its main components also, and then we'll move to CDS. We will have a brief introduction to the CDS and its concepts and also the methodologies of the CDS, and then at last we will cover the Camunda CDS integration and we will end with the demo. So business process management notation is a standard for the process modeling and it is owned by the object management group. OMG is the standards development organization and BPMN will provide the business with the capability of understanding their internal business procedures in a graphical notation, and it's in a XML schema specification. Whatever we design in BPMN, we can check it out. It will be in a XML specification. Camunda is an open source BPMN engine which is compliant with the 2.0 specification, and it's a Java-based framework which provides an intelligent workflows. And we use a Camunda Modeler, which is a UI to design the workflows in the Camunda. And it's a Camunda is a Java-based process engine library which is responsible for executing the BPMN 2.0 processes actually. We have like different components in the Camunda. Like one is the BPMN actually, and another one is the case management module and the notation. This is also a specification by the object management group actually, and we use CMMN is a standard for the modeling cases, and BPMN is a standard for modeling processes actually. That's the difference. We have another component, decision model and notation. We call it as DMN actually. It's a DMN tables we call it. It's a decision tables which internally uses the FEL field expression language. Usually we use these DMN to configure any rules and all which is required for the given use cases, or if you want to store any configuration for a given use case, we go with this DMN actually. So, and also Camunda uses a relational database to store all its state related information. Camunda Modeler, this is a UI actually, which is a user-friendly desktop. Using this modeler, we can design the workflows and all. This provides notations like as we can see here, right? It provides a different notation where we can do a drag and drop to design our process actually. And this is this is compliant with the both BPMN and DMN standards. Okay. Next, we will move on to the architecture of the Camunda. Camunda has a main components like all these components are divided into two phases here, as we can see. One is the design phase and another is an execution phase actually. Modeler is the Camunda UI desktop application where we design the processes actually. So this comes under the design phase. Task list, this is a out of the box web application which comes in with the Camunda, and this is tightly integrated with the Camunda actually. So when we deploy any process, and if that process has any user tasks which needs to be worked upon by the user, then all that tasks can be seen in the task list in the Camunda web application actually. Cockpit is another web application which is used for the process monitoring. For example, if you have deployed any process, BPMN process, and it is still running, through the cockpit, we can check like what is the status of the process. Like if a process has like 5 tasks, like what tasks are completed, which tasks are still in progress. All the status monitoring we can check in the cockpit. REST API, it is used to interface with the external components. The goal of the REST API is to provide the access to the engine interfaces actually. So what are the process engine interfaces we can access through the REST API. So like custom application, we can have our own custom applications, and through the REST APIs, we can access all the engine interfaces actually. And this engine interface will be connected to the database, which stores all the process states. That information, everything would be stored in this relational database. Okay. Next, we'll move on to CDS. CDS is a framework which is used to automate the resolution of the resources for the that instantiation and any config provisioning operations and all. We have a different concepts in CDS. First, we'll start with the data dictionary, which is a list of parameters which to be provided. We will provide this data dictionary in a file actually in a CDS, and these parameters will list down the parameters, and this to be resolved during the runtime actually. Next concept what we have is the resolution. We will provide the values to this configuration parameter during the runtime actually. The source of these values can be we can provide through default values, REST or SQLs, all that things. This is like input parameters what we provide. Next is the configuration provisioning. This is used for the like a complex interaction with the southbound APIs actually. So CDS provides us workflows, and we use a scripts actually. Like in the script, we can use a Kotlin or a Python script to write the code actually to interact with the southbound APIs. All that. So if you all this interaction code can be written in the script actually. Modeling is another concept. This modeling defines the data dictionary resolution workflows and the scripts which is part of this configuration to provide provisioning, and the CDS uses the Tasca and the JSON for the modeling, and all the model information would be stored as a CBA. CBA is called CDS Blueprint Archiver. CBA, we will have the data dictionary, the resolutions, all these scripts, everything would be part of the CBA. And then in the CBA, we deploy this CBA, like we deploy and enrich this CBA into the CDS, and the runtime we can access this CBA. We have in CDS methodology, we have two phases. One is the design phase and another one is the runtime. In the design phase, we have all about this modeling, creating the data dictionaries, resolutions, workflow scripts, like workflows should include like what are the southbound APIs which to be called, all that that coding, logic, everything as part of the script would be done in the designing. In the runtime, we will deploy the whatever will be done in the design time into the CDS, and in the runtime we will trigger the CBA. So in the design phase, we'll design the CBA. In the runtime, we will call that CBA, which invokes the required action on the southbound interfaces. Actually, the southbound interfaces can be a REST, CLI, gRPC, for the different interfaces which we are scripted in the scripts actually and workflows. Okay, so now we have come to okay, now till now we talked about Camunda, and then we talked about CDS, how it works actually. Now we'll start with the Camunda CDS interaction actually. How we can combine these two components here. So this workflow talks about the synchronous actually. So here we have a Camunda workflow, which is a synchronous process. Here this is the actor which calls the workflow. This call can be any REST API, and also from the UI also we can call this Camunda workflows. So this Camunda workflow, like this, just an example, like in this example, this workflow will call a CBA workflow 1 actually, which is deployed in the CDS. So in the runtime, we trigger this CBA. This CBA like returns some values back to the workflow. Again, we will call a different CBA workflow, and then this returns the response. Here in the workflow, we can consolidate all the responses which we received from the CBA, and whichever format which we have to return back to the like the caller, right? We can put it in that format and we can return back to the consumer actually. So here, when we return back this one, each process will have the unique ID, what we call as process UUID. In a synchronous format, the response should be in a standard format actually. So for each in the response, we can find that UUID, and if you are returning back the response data also we can see it actually. So this is a synchronous where the workflow will execute all the like the CBAs, all the things, process this, and then at the last only it will send back the response to the caller. Here, in this case, this is an example for the asynchronous actually. Flow is, we will call a workflow. This workflow would be defined as an asynchronous workflow. When a user calls this workflow, what it does, it will immediately returns back the response to the user with the process UUID, and then in the background it will call all the whatever the CBS which is configured here in the workflow. It will call all the things and it will store all these responses into the Camunda cache actually, and it will be stored into the relational database. If we want this response to be sent back to the user through some other REST API which that user has exposed then we can post the response to that REST API, or by default, all the responses would be stored in the relational database, and the user can poll the use the other standard Camunda REST APIs to get the status of this workflow, whether it is still running or completed, all the things, and also the response data also they can get it with the standard REST API, which is exposed by the Camunda. So here, when we go with the asynchronous workflows, if we have any CBAs which are very long running, like for example, a CBA is taking like a 1 hour or 2 hour or days to complete, something like that, then we'll go with the asynchronous workflows actually. Okay, this is example of the BPMN. Here, this is a synchronous BPMN. So here, this is designed in the Camunda Modeler. So we should have a start button here, like to start a process. Here, this is the DMN table where we are configuring some of our CDS IP address, port number, access details, we can say. Access details are configured into this DMN table. And next, these are the boxes. What we see is all like the tasks actually in the Camunda. Task 1, 2, 3, 4, like that we can call it actually. So once we load this DMN table, we are reading that data there and we are creating the payload, and then we are sending the payload to the CBA. So the first call goes here to the CDS. So first we'll call the CBA1 here, and then we'll get the response, and we will parse the response if you are getting success or failure. If you are getting the success, then we'll call another CBA, and this CBA is part of the sub-process actually. If it is a failed, if the first CBA only failed, then we will end the workflow here. So these are the different notations here. This is the sub-process what we have here. So it's the same thing. We have a different tasks here, which creates the payload, send the request to the CBA, parse the response. If it is success, we'll have something, some logic here. For the failure, we'll have some logic. At the end, it will do the end actually. This is a synchronous BPMN process example. Now I will show these. I will have a demo like how this workflow can be called actually. Let's go to the demo. So here we have a setup where we are running the Camunda and CDS as part of the Kubernetes pods actually. We have Camunda is running and also CDS Spy executor, all that. First here, these are the steps which will be covering in this demo. We have two sample CBAs, steps Spy 1 and multi-steps 1 actually. This two CBAs is already deployed into the CDS, means we already done the design time here. What we do in this demo is runtime. We will call this CBAs actually. So we have two CBAs which is already deployed. We will call this CBAs through the workflow. That workflow name is PROCESS.bpmn test main actually. We have a sample 1 and sample 2 actually. So we have a command to check whether it's deployed or not actually. So here it is the first CBA which is already deployed actually, and we have another CBA which is also deployed and it's available in CDS. This is like we are calling the CDS to know like what are the CBAs already deployed and available. So the 2 CBAs are already deployed here. Here we will go to the Camunda console actually. Here, I already deployed this BPMN test main process into the Camunda. So we will go and check in the console the deployment. This is the Camunda console. This is the task list console actually, where we can see the tasks which are to be taken care by the user. But for our process, this is not applicable. So here, this is the cockpit, Camunda cockpit console. Here we can see what are the process deployed. It will show the number, like how many things are deployed here, and what are the process instances which are running. All that information we can check in the cockpit. This is a web application which comes with the Camunda. Next, we'll go to the deployments. The one which we are interested is this, the one actually. This is the main process which calls a CBA, one CBA, CDS CBA, and then if it is successful, and then it will call another CBA actually. So CBA 1 and CBA 2. Once the CBA 2 also is successful, it will print the success and then it will end the process. So whatever we deployed in the Camunda BPMN engine, we can see that this is just a deployed, but we can still see what is deployed in the console also. So this is the main one which is deployed, and we'll also see the sub process which is also deployed. So in this one, what we have is we bundled all these BPMNs, DMNs into a war file actually, and its corresponding the logic files, right? It can be a Java. In this case, it's a Java files, but we can use other Groovy scripts also to write the logic. All that logic files, BPMN, DMN, and the configuration files, all that we bundled into an war file. And this Camunda is a standalone Camunda engine where we deployed this war file. So when we deploy this war file, we will see all the BPMNs which are part of that war file. This is the DMN file which we deployed, which contains the configuration information of the CDS, like what CDS has to be called from the Camunda workflow. Now we deployed the workflows which is already there in the BPMN engine. Now we are going to call this process. So this is the REST API to call the workflows actually. This is which is already provided by the Camunda engine. We have to specify the workflow name and then do a start actually. This is the syntax which we use actually. So here I'm through the curl command, I'm triggering the workflow. This is a synchronous Camunda workflow. So we should get the response after completing it actually. As we can see, we started the workflow, it's completed, and we got the response. And all these attributes, whatever we see, right, in the workflow, if we are using any variables to store any that information, all that variables can be seen here as part of the output also. So in our case, the CBA output we have stored as part of this response out variable. So the response out variable will have the CBA response. This response is we received from the CDS CBA when we call, and it returned the response status as 200, as we can see here. This is the response which we got it from the CBA to all this, and each workflow process will have an ID. This ID we call it as process UUID. When we trigger any workflow process, it will have an ID, and in the relational database of the Camunda, with this ID only, all that information related to this process would be stored. And later point, if you want to read that information, we can use this ID to get all that information. These are the different variables which is used in the workflow actually. All that would be returned in the synchronous section. Okay. Next step, what we do is, if we have a asynchronous workflow, right, we are not going to get that the response immediately. What we get is, we get only the process UUID. And if you want to check the status of the process, like whether it is still running or still or it is completed, or the status of the process, then the Camunda process engine provides a different REST API actually, the one I'm showing now, right? With that API, we can check the process status actually. So in this example, I'm just taking the same process ID which we run previously. So we will take the same process ID. And we'll just do a get status of the process. Now, as we completed the process, it should return as the completed status. As we can see, the state is completed, and it provides us what is the start time, end time, what is the process instance ID. This is the standard details which will be provided. And also the one which will be interested is the state actually. If it is still running, then it will show the active status. If it is completed, then it will show the completed status actually. So in the workflow also, if you have any long running process, for example, the asynchronous process, if you have, and if it is still run in some of the tasks, if it is still running, then we can also check the status here in the cockpit actually. If, for example, if the send request is still it's still active, and if it is still running that task, then we can see the pointer there actually. So through the cockpit also, we can check the status of the process. So here, if you go to this process, right, it will show like 0 running instances of the main and sub process, as it is already completed. So it will show 0 actually. If the process is still running, then it will show the running instances as 1 or 2 based on the number of things that instances are running. Here, so this is like same thing. If something is running, we can just check come over here and check the status of the process actually, all these ones. Okay, we're done with the demo. So we're done with the session. Like now, Any questions? Does anyone have any questions?
Yeah, thanks, Kavita, for the interesting session. There are a lot of questions coming up. Let me give few seconds. Okay, how CDS CBA is getting involved in Camunda workflow? Is Camunda makes a REST call to CDS?
Yeah, that's right. To call a CBA, we have a standard REST API, which is part of the CDS. Through that REST API, we call the CBAs actually. When we call the CBAs, the corresponding CBA request payload and all we have to define, like what is the workflow name, and what is the type. If the CBA is using the PI executor, then we have to mention the PI executor IPs, all that. So the request payload we have to construct, which is accepted by the CBA. And then through the standard CDS CBA REST API, we will call the CBA through the Camunda workflow.
Okay, thanks, Kavita. There's one more question. What database does Camunda use?
By default, Camunda uses H2 database actually, but we can configure any relational database. In our project, we configured the MariaDB. It supports MySQL, MariaDB, the relational database.
Okay. DMN concept is not clear. Is each box here is a DMN?
Sorry, where?
I also am not able to understand it.
So here, okay, this is a DMN table actually. Okay, this is a task, but the task type is a DMN, but other things, as we can see, the icon notations are different. So this is a task which is a script task actually. Okay, this is a service task. So only the DMN in this one is this one actually. Components DMN, which shows icon as a table here. This is only the DMN. All others are service tasks are a script task actually. So this DMN as the configuration of the CDS. So the previous question they were asking, right? The CBA, what the REST API endpoint of the CBA, all that configured here actually.
Okay.
CDS port number, APIs, all that configured here, so that we'll read that one and we will send this payload, CBA payload, to that REST API.
Okay. Is there a UI component for the REST call that initiates the workflow for any follow-up user interaction task?
Usually from the Camunda console, we can start the workflows also. There is a UI. So from the Camunda web application, right, there is one thing from where we can start the workflows also. Web once, let me see if I have a screenshot. One second. Just go back here. In this right hand corner, we will see one more task list, and then we'll see one button like start process. Okay, if you click on the start process, it will open one pop-up where we need to the pop-up will show all the processes which are deployed in this Camunda engine. For example, it will show test sub process, all that one. We have to select that, and then we have to do a start actually. So then it will start this process actually. There is a button like start process here. Using that also we can start the process.
Okay. Okay, someone is asking me, will the recording of the session will be made available? Yes, definitely. I'm recording it, and on demand I can, circulate it. And we'll also upload in the YouTube channel. Okay, does this CDS workflow been integrated with AMCOP orchestrator CNF workflow? Or isolated?
Yeah. No, Camunda is already part of our AMCOP release actually. It is when we install AMCOP, this Camunda also comes up as one of the Kubernetes pod.
Okay. Okay. Any more question? Okay, one more I can see. Can we run Camunda engine as a standalone with existing web app server?
Yes, actually, Camunda has two types of supports two types of processing engines actually. One is like an embedded process engine where we have a Spring Boot starter kit, and workflows would be embedded as a single web application bar file, and ONAP community uses this embedded process engine. And in AMCOP, we go with the shared processing engine where we go with like a container based with the which can scale multiple nodes actually. So here and also all the pluggable workflows will be loaded as an individual war files actually. So with the shared processing engine, standalone process engine, we can deploy any number of war files into the Camunda engine, but with the embedded one, we can just deploy only one war file always. So better to go with the standalone, so where we can just deploy any number of custom web applications. So AMCOP uses this shared process engine actually.
Okay, and I think there is a repeat question, I think, which you have answered, right? Is there a UI component for the REST call that initiate the workflow? I think you have answered it before it.
Yeah, that's right.
Yes.
It's already there through concept.
Yes, yes. Is there any model-driven recipes selection available in Camunda?
Model-driven? No, actually. So actually in AMCOP, we have come up with the templates actually, but in a ONAP community site, we don't have any like any templates available. But in the AMCOP, we have the templates actually for the CDS and all from the Camunda.
Okay. Can you show some example of task implementation? Where do we tell that for this task we will be Groovy, for other tasks we will use Java?
Okay, I just have to I'll just unshare my screen for a minute.
Okay. Yeah, Kavita, there is one more question and then we will end it up, okay?
Okay.
Are you searching something or should I just?
No.
There is
I'm
no,
there.
okay, there is no, this one question which has come. Okay. Okay, show please. Yeah.
Okay. This is the test process, what I have we deployed and we tested and which is a part of our demo actually. Each one would be a task or something here, right? Each one, if you have a click, then we can select, if you are going with a groupie, then we can mention here, which is inline script. You can put all the scripting language here. If it is a Java, then we can, I'll just show you that another example here. I'll just put here on this one. If you want to use a Java, then just select the service task here. And then on top of that, you have to mention the Java class, and you need to put the Java class, which Java class has this logic actually for this service. You need to mention the full path here actually. And then that when the workflow started and the pointer comes over it, then this will call this Java actually, Java class, whichever it is mentioned here. Okay. These are the different notations, which is, this is a modular, Camunda Modeler, where we do a drag and drop actually, something like this. And we need to configure what is the task, each task does. Yeah. What is other question?
Okay, there is no separate orchestration pod in AMCOP, right?
AMCOP as a, like, okay, we have a Camunda Kubernetes part, which acts as a service orchestrator. Camunda is used as an orchestrator in case of AMCOP actually.
Okay. Okay, I think it's very interesting session, Kavita. We should do one more time. So thank you so much, everyone, for joining us. We will be back soon with something new in the month of May. Till then, good night and good day. Thank you so much, Kavita.
Yeah, thank you all. Have a good day.
Bye-bye.